Okay, let's get through some actual math today. We're solving by substitution. This is our second way of solving systems of equations. And this one is really good if you are given the value of one of our variables. So this one, it tells us x equals 7y plus 11. So it doesn't really tell us what x is, but it's got x isolated. We can work with that. So what we're going to do is we isolate one variable. In the case of today, it's done for you. And then we're going to take that value and we're going to substitute the x in the second equation with that same amount. So I know that doesn't really make sense unless you see it. So I'm going to rewrite this bottom equation. So 5 times, only I'm not going to put x, I'm going to leave it blank for now. So plus 4y equals negative 23. And then I'm going to substitute that x with what I know x equals, which is 7y plus 11. Okay? So now we just have a multi-step equation, but there's only one variable. There's only one variable we can solve for that variable. So we just go through our steps. So we start by distributing. So 5 times 7 is 35y. 5 times 11 is 55. Bring the rest down. 4y, negative 23. You're going to combine your like terms. So 35y and 4y is 39y. We want to bring this 55 to the other side. Actually, let's write out all the steps. Let's not be lazy. 39y plus 55 equals negative 23. So minus 55 to both sides. Quickly running out of room. So 39y equals, this will cancel. Negative 23, negative 55 more is negative 78. So we just divide both sides by 39. And that will give us y equals negative 2. Yeah, that's what I have for. Okay, so once I know what y equals, I can take that value, I can put it back into either equation, and then I can solve for x. So let's do green. So let's rewrite this equation, our top one. So x equals 7 times, we're not going to put y, we'll come back, we'll change the color here. So y we know is negative 2. So we just work that out, so that's negative 14 plus 11. Negative 14 plus 11 is negative 3, so x equals negative 3, which gives a solution to our system of equations here of negative 3 comma negative 2. And then we can check it if I put that x and y value into my other equation. So 5 times negative 3 is negative 15, plus 4 times negative 2 is negative 8. So negative 15 plus negative 8, that does equal negative 23. You can trust my mental math, it's pretty good. Okay? So we isolate one variable, substitute into the other equation, solve for either x or y. Once you know that, you put that value back into an equation to solve for what's missing, and then you have a nice ordered pair. Not too bad. It's a little bit of work. But once you get in the hang of it, you'll see it's not too bad. So let's try one more. So number one, it tells us y equals 5x minus 10. Okay, cool. So I'm going to rewrite this top equation, only instead of y, I'm going to replace with 5x minus 10. So 6x minus 5, and then we'll put 12, and then in green here, just to color coordinate, we're going to put 5x minus 10. And then we're just going to solve it. So if we distribute here, so the reason I want to do this one is so you don't make any mistakes here. Since it's minus 5 outside, it's going to be minus 5 times 5x, which is negative 25x. And then minus 5 times negative 10 is positive. So it's going to be plus 50. Okay? So we combine our like terms. So 6x minus 25 is negative 19x plus 50 equals 12. So now we just get x by itself. So minus 50 to both sides. So we have negative 19x equals, that's going to be negative 38. So if we divide both sides by negative 19, we get x equals, that's going to be 2, and then a negative divided by a negative is a positive. So we get x equals 2, which really narrows down our choices here. But just to be sure, right, no mistakes here. So if x is 2, if I put that back into my second equation here, so y equals 5 times 2 minus 10. And then that math's not too bad. 5 times 2 is 10. 10 minus 10 is 0. So y should indeed equal 0. So that gives us our equation, or not equation, our coordinate 2, 0, which is indeed answer C. Okay? So try them out. If you need help, send me messages through the old Canvas. Okay, bye.